Hi everyone, are you able to hear me?
Yes,
Okay, so my name is Raghubir Prasad, and in this series of workshops of Microsoft Monthly, we would be going forward with blockchain development. So, blockchain development has recently come out to be one of the most hyped up fields in the world of software engineering, mainly because of its decentralized approach. So, right now, up until Web 2, what we have is that we have websites that are run by massive corporations. Like, let's say we have Instagram, for example, that is run by Facebook or Meta. And similarly, Facebook is also a website that is run by Meta, YouTube or Gmail, Alphabet or Google has the access to this. So the main issue with this is that all this is centralized. All your data, whatever you store in Google Drive, for example, goes into the servers of Google, and they do have access to all your data, and even your passwords are stored in their databases. Even though it is hashed, even though we can say that it is in a way secured, but still we can't right away the fact that all this is actually stored on a central server. So that's where the concept of Web3 comes in, where we actually want to make a world of internet which is actually more decentralized, in which we also get the added advantage of more anonymity, better verification of all the things. So we would be discovering Web3 in these 4 sessions, which would be happening. One is today, another one is tomorrow at the same time. Then we would be tuning in next week, Saturday and Sunday, same time again. So let me set the course for these 4 workshops first. So a rough idea in this session, we won't be coding as much. We would be seeing a IDE which is used for Solidity development, that is Remix. We would be writing some simple smart contracts, nothing very heavy. We would try and get download wallets in our browsers. We would be downloading the Chrome extensions, and then we would be setting up our public and private keys and all that stuff. So, apart from that, let us set a course for the next 4 sessions as well. So, in that, I'll just share a brief idea that I have. So, in session one, we'll be starting with what is blockchain, what are ledgers, how are blocks and chains being hashed and stored, and then we would be going a little into cryptography, what are public and private keys. Then we would understand how the blockchains work. So there are mainly two proofs or consensus that we use in this world, which are proof of work and proof of stake. So we would be seeing how that works. And then finally, we would be moving forward to a basic environment setup, where we would be setting up MetaMask as a wallet and exploring a few other wallets as well, like Phantom and Backpack, and finally setting up the Remix IDE, so that when we tune in tomorrow at the same time, we are ready to begin with our Solidity development. So anybody who wants to answer what is a blockchain? Just quickly, if anybody has any idea. Come on, you can
It's
say
like this,
blockchain is a chain of blocks.
like a digital ledger, you could say.
A digital ledger, great. So digital ledger is fine. So it is basically public. So anybody can see what all changes are happening on the blocks, but and anybody can modify as well. But the main central idea is that nobody should be able to misuse this. That tomorrow, let's say, I shouldn't be able to go back in time and change a block. So let me share a few slides. Nothing that much, to be honest. So let's start. So one of the main things or uses of blockchain is cryptocurrency, right? So first, let us go through some backstory of how currencies actually developed around this world, and why we needed currencies, and how modern day currency became a thing, and then finally how did we uh, move on to the current cryptocurrencies. Let me try and share my slides. So, why did we need currencies in the first place? Anybody wants to go ahead? Like, why do I need dirhams or why do I need rupees?
Maybe to like complete transactions.
Yeah, to complete transactions. But on a very fundamental level, what we are taking against currencies or against currency notes are products or services. So why can't we trade services directly? Or in other words, if I put it, why can't the world run on barter system?
I think it's because the value of different commodities or different services is different on certain levels. That's why the certain value is assigned to that service or commodity.
Okay, I assign some value, but maybe you and I can come on a consensus that, let's say, product A which I make and product B which you make, we would trade that on a 1:1 ratio. Still, do you think that would be a fair thing to do, or would that be optimal, so to say?
No, that's what I'm saying. That I don't think that would be optimal because your product can be different and my product can be different of different value.
Yeah, so behind this, what the main reason was that maybe I don't need the product that you're producing. So let's say you're producing some product B, I am producing some product A. You might need my product and I may not need yours, or vice versa. So in this case, we need some asset that all of us can come on a consensus on, that okay, let's say if I have certain gold, you would give me your product, and then I can take that gold, go anywhere and trade that for any commodity that I like. So it gives me the flexibility to choose whatever product or service that I may want, and not limited to the one that you are providing to me. So yeah, modern day currencies. So the US dollars was the first modern day currency that was pegged by gold. So people thought, instead of carrying gold, which is like, it is not easy to carry gold, right? You can't take 1 kilo of gold and transfer it from one country to another. Whereas if you have dollar and you're in the Swift ecosystem, you would be able to transfer that money rather quickly. But the thing was, in 1971, US was going through a very major recession, and they just abolished this gold standard. And they didn't tell anyone, but they were just like, okay, from now onwards, we would just be printing money. And they didn't have as much gold to back that currency with. So then we moved on to an era where the US dollar was like the centralized currency, and every other currency was compared with the dollar, and that's how we moved on. So like nowadays, rupee is touching about 95 to a dollar, which was 70s, 80s back in the day. So are we getting, like, we are moving more towards a centralized ecosystem, which is why like people started thinking in terms of cryptocurrency, where everybody can have a say. So how many of you have seen the movie The Big Short? Can we get a quick raise of hands or just put it in the chat? Yes. Okay, so it is based on the 2008 financial crisis. Again, after the Lehman Brothers crash, people actually started noticing how much power these centralized banking institutions have in our modern day world, and how whatever assets we own, be it fixed deposits, be it stocks, they are actually, they don't have any underlying asset. Because gold was actually valuable, because tomorrow I can't go and mine, let's say, tons of gold, and the demand will rapidly increase. That won't happen. But if you look at the US dollar, tomorrow if the feds decide, they can just go on and print as much dollar as they want. And that actually leads to hyperinflation, which is what happened in Venezuela, which is what happened in Turkey as well. Like Turkish lira, if you see over the past few years, it has like depreciated a lot compared to the US dollar. So Seeing that in mind, we get a timeline of how the cryptocurrencies evolved. So in 2008, we have the global financial crisis. In 2009, the Bitcoin white paper was released. I'll share a screenshot with you in the coming slides. And in 2010, it's a funny story. I have the YouTube link. We'll share the slides with you. You can go ahead and watch it. So there was a man who had about 10,000 bitcoins. Now, 10,000 bitcoins, if you look at it from a today's point of view, that is a huge amount. Like in INR, Bitcoin is worth about 100. In USD, it is about 100k US dollars. So 10k, which means a person just bought a pizza for $10 million. But that wasn't actually the case, because back in the day, nobody realized that Bitcoin would explode into such high values and that it would be such valuable later on. So a guy just bought a pizza for 10,000 bitcoins. And in 2015, there were certain like fundamental issues with Bitcoin. Like you tomorrow, let's say if I want to create a coin called Raghu coin, I can't do that with Bitcoin per se. I will have to use Ethereum, because when Ethereum was developed, the blockchain was such that on top of that I can add my own tokens. Then Solana was formed. So basic difference between Ethereum and Solana again being that when we create a blockchain in a block is basically a group of transactions that happened on the chain. So let's say if I send 0.00001 Bitcoin to somebody, and that someone again trades that and transfers it to someone else, what will happen is all those transactions, there will be various servers around the world which are called validators or miners. And the job of these validators are to basically verify the transaction that is coming and to record it on the blockchain. So, basic difference between Ethereum and Solana is Solana supports parallel processing even within the blocks. Let's say if I have thousands of transactions within a block, Solana can parallel compute them, whereas Ethereum can do them only sequentially. Apart from that, in COVID 19, again, when the world was facing a crisis, US Fed started printing a lot of money, which again led to inflation. And in 2021, NFTs became a new thing. Like everybody was talking about NFTs and how, like those monkeys, I don't know if you have seen, they became very popular. And in 2025, Trump also launched one of his coins, the Trump coin and meme coin. We have seen Dogecoin as well. So this is a basic timeline. So here we have the Indian rupee. Like if you see, since 2021 it was 74 rupees to a dollar, and today if you see, it is roughly 93 rupees to a dollar. So this inflation or loss of value against a central currency is what we try and tackle with cryptocurrencies. So this is a Bitcoin white paper. As we all know, Satoshi Nakamoto is like a figure who basically released Bitcoin and published the Bitcoin white paper. And it was like a peer-to-peer cash system. So tomorrow, let's say, if anyone on the internet wants to hold some Bitcoin, they can simply do it using a public private key system, which is not the case, let's say, in central banking institutions. Let's say if tomorrow I want to open an account in ADCB, I need to have my Emirates ID, I need to be 18 years old. But with cryptocurrency, that sort of just fades away. Let's say tomorrow a 2-year-old creates a public private key on his own device, and then he or she can use it to just access the blockchain and buy and sell Bitcoin or any other cryptocurrency for that matter. So let us start with a few basics and understand difference between three main things: encodings, encryptions, and hashing. So firstly, what is encoding? So we know that our computers understand only zeros and one. So what encoding does is we have various protocols like ASCII, base 64, base 58, hex, and UTF-8. All of you might have heard the names. So we can store different letters, numbers, and integers, floats in these formats, which then convert these to bits and bytes, which our computers understand. So this is basically encoding. So I can encode my string, let's say in ASCII, or I can encode my string in base 64. Those of you who participate in CTS might know. Similarly, UTF-8 is a very popular encryption that is used in web pages and all. So now moving on to hashing. So what hashing basically does is it is a one-way street. So let's say if I have a string called hello. Now once I hash it using some hashing algorithm, I will give this random cryptic key, which is, let's say in this case, ASD 912 something something something. So this is a process of converting data like a file or a message into a fixed string of characters, which one of the main advantages is that they are random. So let's say I open a SHA-256 uh, encoder, a hashing tool. Just wait a second. Yeah. So let's say I have this SHA-256 generated. So SHA-256 again is a hashing algorithm. So I write hello, I get this hash 2CF4DBA. Now, even if I make a small change, like I just remove one L, this will change substantially. So it is not at all predictable. Like I make a small change, but the hash that I get would be completely different. And another major advantage of this is, like, let's say uh, I have the hash. There is no way from the hash I can get what my input value was. So, like, there's no way from this F4, E4, 54, if I use some any algorithm that I put, I can't get HELO. The only way to get this hash is if I brute force, like if I start from A, let's say A, B, C, D, E, F, G, H, until I get to HELO, I won't get this hash. But every time that I go and hash HELO, I'll get this itself. So it is deterministic, but one can't backtrack it to the input value. Apart from that, now let's move on to encryption. Just a second. So SHA-256 is an algorithm that we just see. And now let's move on to encryption. So encryption, again, as most of you might know, is a form like of just converting plain text data into its into a ciphertext. And the main thing is that there should be some way of decrypting this ciphertext so that we get the original key. Now, how do we go about doing that? Let's say I have some plain text hello, for example. I decrypt it using some algorithm, and I can get a ciphertext which I can then decrypt. But there are two main types of encryption algorithms that we'll see in the next slide. Let us first see the key features, that it is reversible and it is key dependent. So, is there a way that one part of the key is known to the world and it still stays as encrypted as it was, is what we'll see here. So there are basically two types of encryption. One is symmetric encryption, which basically means like if I encrypt hello with a key and get this, when I decrypt using the same key, same being the keyword, I should get back my plain text, which is hello. But another one which is more useful to cryptographers is the asymmetric encryption. In this, we have two keys, one public key, one private key, which is used for encryption. And once you have the encrypted text, once you give the encrypted text, the decryption key is a public key. So, how can we go ahead in utilizing this in, let's say, cryptocurrency or blockchains? So, or this is also used in digital signatures. So, nowadays, that we see in Adobe Acrobat, if you want to sign a document digitally, there should be a way to verify that if Raghubir Prasad has signed a document, it is done by Raghubir Prasad itself. And everybody should be able to verify that, but nobody should be able to sign that document on my behalf. So this is where private key and public key come into picture. So private key is basically the one I'll use to sign that document. Now once I sign that document, I send it to anybody who needs that document, they will have a public key using which they can only verify that yes, the document that has been received by me was actually signed by Raghubir Prasad and not some person trying to impersonate him. Although, like, if you just sign and scan and send it, people can like Photoshop that and they can just crop my signature and put it on any document that they want. But if I use a private key which is known only to me, then it becomes sort of difficult to like tamper with the documents. Another important use case is in the cryptocurrency wallets that we have, be it MetaMask, be it Phantom or Backpack. What we get in a wallet is basically a public and private key pair. So whenever this happens is public key, you can share it to anyone, so you can receive money. But when you have to send the money, you will need your private key to authorize that transaction on the blockchain. So that is where it basically comes into picture, asymmetric and symmetric encryption. Now you might wonder, can we create a asymmetric key pair in our own laptops? Like, how do we go ahead and do that? So all of you can try this. If you can open your terminal, be it PowerShell or the terminal app if you're on your Mac, and follow along with me so we can just like try to create a public and private key for ourselves. I'll share my screen. Just a second.
Excuse me.
Yeah.
This that this is only in Mac or in the normal like desktop also.
You can do this in PowerShell as well. I would be showing this on a Mac, but you can use any PC.
Okay.
So yeah, once you're in your terminal window or in your PowerShell window, just type ssh dash keygen. So generating a ED25119 key pair. We, in the next few slides, we would be seeing what this actually means. So enter a file in which you want to save the key. So it is suggesting me a path. I'll just copy this path and paste this. I missed a 9. And since I already have this key created for me, what I'll do is I'll do _2. So it just doesn't overwrite what I have. So enter passphrase, we can just leave this empty. So now it says the fingerprint is, and it has generated my key. Now how do we go ahead and see this key? We will do cat and we'll just put the path that we just created. So this shows you my SSH private key. Okay. Now this is the same key that is being used in modern day wallets, like whether I create a MetaMask wallet or whether I create a Phantom wallet, which we would be seeing the practical side of in a few minutes. This is the same private key that I'll use to authorize any transaction. Obviously, that will be a different key that will be generated by their system. But let's say if I want a fully system that runs only on my laptop on a hardware basis, then I can utilize this private key itself. And if I want the public key, I just do .pub. Then this gives me the public key that I have. So again, this is the public and private key pair. I can use this to digitally sign documents. I can use this to authorize cryptocurrency transactions. Has anybody of you tried, like on your laptops? Okay, that's great. So yeah, let's move on. Now, let us see some asymmetric encryption protocols. Just a second. So yeah. So what this actually does is the public and private key that we generate is based on an elliptic curve. So we have an ellipse and we select a random point on that ellipse, which actually gives us this public and private key pair. So one of the oldest algorithms was the RSA, which also was generating public private keys. But nowadays, what modern day blockchains use are ECDSA and EDDSA. And ECDSA is used by Ethereum and Bitcoin, whereas EDDSA is used by Solana. So I have this YouTube link of how elliptic curves work, but for now, let us just skip that and we have some common elliptic curves. So what this ECDSA algorithm uses is the SECP256K1, and what the EDDSA algorithm uses is the another curve ED25519. And if you looked carefully, the public and private key that we just created on our local terminals was the same ED25519 key that is used in Solana as well. Now, few use cases are again in SSH protocol. So if you use GitHub, you have a SSH link as well when you're trying to clone a repository. So if you have your public and private keys set up on your local device, you can just use the SSH link, or else there are many other ways to clone as well. So again, this is creating a public and private key pair. You create it, you define a message that you want to sign. You sign it using the private key, but when it comes to verification, that is being done by the public key. So nobody can tamper with the documents that I have. Like nobody can say, I have signed on behalf of Raghubir Prasad, because my private key will only be with me. But if anybody on the internet wants to verify that whether this document was actually signed by me, it is possible because we are using these. So again, as we saw, the two elliptic curves, which we used. So one used in Bitcoin and Ethereum, and the other one used in Solana. I'm so sorry for the inconvenience, guys. I had a network interruption. So let us continue from where we left. So what we were discussing were how we create a public and private key. Now let us move on to, let's say tomorrow if I want to create a blockchain, let's say I want to create a coin called Raghu coin. How can I go ahead and do that? So, while doing so, we would be figuring out how these blockchains work and how are they so secure. So, in order to create our own cryptocurrency, we'll first actually need to write a program that people can run on their machine to become a part of our blockchain. So, let's say Bitcoin, for example. Bitcoin has a very vast, like people who are miners. There are massive server rooms that have GPUs and all, which are just dedicated to one thing, which is mine more and more Bitcoin. So first I need to create an algorithm that like that. Now second step is I need to write a program that dictates how much currency is minted, when, and who gets the initial supply. So what happens is, just like when a new Nike sneaker is dropped, for example, there's a huge line in front of the stores, right? Similarly, like blockchain developers do airdrops. So the initial few developers, they try and attract them by giving bonuses. Like initial investors, they get more cryptocurrency in hopes that when in future the price of this token rises, I'll probably be able to recover my initial investment. So, and the major thing is anybody can join this blockchain. So let's say anybody joins this, to send or receive Bitcoin, as we have seen, they need to create a public private key pair and no need of usernames or passwords. And again, to send Bitcoin from your wallet to a different wallet, we need the receiver's public key and we need to sign it using our private key. Now let us move on to some questions, and while we do that, we'll understand the working of a modern day cryptocurrency. So if anybody of you know, they can move ahead and answer as well. So first question: can a miner move money from one random address to another? What do you guys think? Should this happen in any cryptocurrency?
No.
Yeah. And how can we ensure this? So, who holds the private key? Only the sender has the private key which can sign the transaction. So, even if let's say tomorrow I am a miner, so and I receive this transaction to be added in my block. So, what will happen is, because I don't have the uh, transaction key, the private key, the other miners that are on the network will reject my chain because it is not signed by an authentic key. So then it begs the question, because there are so many miners around the world, people want to mine cryptocurrency and earn money, because whenever you mine, you receive some cryptocurrency as a reward for executing that transaction. So here is where the concept proof of work comes in. Let's say tomorrow you want to become a Bitcoin miner. So what you need is proof of work. Whenever a transaction executes on the Bitcoin blockchain, what happens is we need to find a cryptographic hash. In order to find that cryptographic hash, we need a lot of computing power and solve a mathematical question basically. What we actually do is, let me try and open a visualizer and show this to you firsthand. Like, how does this hashing and all actually take place? Okay, yeah. So, okay, this is a demo. So, here I have a chain of 5 blocks, and we will come to what this nonce is in a minute. So, let's say I have some data. Now, what this data would be, let's say one public key 1, decides to send some money to public key 2, and the amount is, let's say, 1 Bitcoin. And then that public key 2 sends it to, let's say, public key 3, and they send 0.005 Bitcoin, just for example. Now when we click on mine, just see what changes. Focus on this hash and this nonce. Okay, can anybody try and figure out what changed?
Nonce just changed.
Nonce changed, very good. What else? The hash changed as well, right? What we find in the
Yes.
hash is it starts with 4 zeros. So when Bitcoin was actually being created as a blockchain, the the creators decided that whenever we want a hash, what we finally need is that it should start with a certain number of zeros. Now, finding this is fairly difficult. If I, because we have this data, the data can't change. I can't say that public key 1 is sending money to public key 3 instead of public. Oh, here I made a mistake. It is only public, it's not public key 3. So if I now mine, I'll get a different nonce, but the hash again has 4 zeros in the beginning, which is the main focusing point of our argument over here, is that whatever this data is, it can't be changed. But what can be changed is this nonce. So let's say I have some new data now that public key 3 sends money to public key 1, and they send 0.0025 Bitcoin, let's say. Now, when I mine this, I again get a hash that starts with 4 zeros. So what they decided was that because finding this nonce is a tough task, and here we only have 1 or 2 transactions, but in real life, we have thousands of transactions within one block and thousands of blocks that go on to finally form our blockchain. So what was decided was the initial hash would be all zeros. That is actually what is called the genesis. So that is, we can think of it as the creation of a new blockchain. So in genesis, we don't have any previous hash, so that would be all zeros. Then we take the previous hash, we take the data that we have right now, and then we try and find a nonce for which this hash has a certain number of zeros. Why was this introduced was because why do we need computing power to validate a transaction? Why, if I just have a small device, let's say I have a phone, why can't I mine Bitcoin on my phone? Why do I need heavy computing power? This was actually made in order to make the supply scarce, because if anybody is able to access Bitcoin, the value will drop over time because the supply will increase. In order to ensure that, they decided that the voting right, the creation right, basically validating a transaction, that shouldn't be given one validation to one IP address, but that should be rather made that one computing power gets one validation. So let's say tomorrow, if somebody has more computing power, they would be able to validate more transactions and mine more Bitcoins for themselves as well. So for that, we created a system of hashing. And this hash that we get, nowadays I think it is about 20 zeros we need to get to validate one transaction. So just to validate one transaction, let's say this person sends it to this person, you need to find a nonce so that your next hash is 00020 times before anything else comes. Now when we move on to this, this is the previous hash. So whatever we get over here is the previous hash. Now whatever data that we have, let's say here we also have public key 3 sending some money to public key 4. 4. BTC. Now when we mine, it will generate a different nonce and a different hash value, which would again be used over here in block 3. So now try and understand one of the fundamental benefits of blockchain. Let's say here it sends to public key 1 and I mine. So now my chain has 3 blocks. Tomorrow, let's say you try and buy a camera with Bitcoin, let's say. So you go to the camera guy, you say that I'll give you, let's say, Bitcoin worth 1,000 dirhams, and you give me one camera. He's like, okay. So you send the you given your private key, you given his public key, and then you authorize the transaction on the blockchain. When it happens, let's say you are public key 1 and he is public key 2, and you sent 1 Bitcoin. Let's say, just for example, 1 Bitcoin is 1,000 dirhams. Once this transaction has taken place, because we have so many miners on the internet, that within a few minutes, right now the time has been kept as 10 minutes. So every 10 minutes, a new block is being created on the blockchain. So whenever that happens, I can't go back and reverse my transaction, which was actually a major issue. Like, let's say I buy something on my credit card and I just dispute the transaction, that would not, the transaction would not take place. And like, the merchant would essentially face a loss because he delivered the product, whereas I reversed the transaction and the money never reached him. But in the case of blockchain, let us say I remove this transaction and I mine. All these blocks became false. So it is not that once new blocks are added, I can go back in time and change any previous blocks. Why? Because this hash changed. When this hash changed, this previous changed. When this previous changed, the new hash that was generated also changed, and so on. So, which again moves us on to the next question, which was related about Bitcoin forking and all. So, let's first see those and then we'll move on. Are you guys understanding till now? Can I just get a thumbs up or a raise of hands? Okay, thank you so much. That is really motivating. So, I'll just share the slides. So, moving on. Which miners should I send my transaction to? So around the world, there are various miners, and no matter whoever gets your transaction, once it is updated on the blockchain, it is a single stream. So all the miners will have the same blockchain consisting of all the data. So let's say public key 1 has, let's say, a balance of, say, 4 Bitcoins. So that will be available to all the validators around the world. And we would be using the term validator or miner interchangeably, so they mean one or the same thing. What if a miner doesn't include my transaction? Now, that is a really interesting thing. So let us say I am sitting in Dubai and we have a validator in Dubai and we send our transaction. Why should he or she include my transaction in the block and actually attach it to the blockchain? Well, for starters, they are getting mining rewards from the Bitcoin creator itself. So they would be getting, if they post, add one more block to the blockchain. Right now, it is, I think, 3.125 Bitcoins. So let's say every 10 minutes, you could be minting 3 more Bitcoins if you have such a high computing power so as to validate these transactions on the blockchain. So what if they don't include my transaction? So for that, we have like a thing called mempool, which is basically a memory wherein all the transactions that couldn't get executed are there. And as and when the miners will get time, they will try and reduce the transactions in the mempool, and finally they will be authenticated. Now, because nowadays transactions happen so fast, and as I told earlier, it takes about 10 minutes for a new block to be added to the blockchain, in the Bitcoin blockchain. So what happens is, if my transaction is not included, there is almost a certain chance that within the next 4 or 5 blocks, my transaction would be included somewhere and it will actually make a part of the final blockchain. But now, moving on, why wouldn't a miner always start to propose a block then? Yeah. So now this creates a issue. If let's say I'm a miner, instead of using the age old blockchain which is running, I create a fork in between and I say that, okay, this is my new block, and I try to game the system. So what the actual logic is, whichever is the longest blockchain is adapted by all the validators around the world. So uh, whatever, like if I create a new chain and try to game the system and try to make my chain as the main chain, what I'll have to do is I'll have to create a new block, and I'll have to execute all the transactions that took place earlier as well. Let me try and explain it through a board. Yeah. So here, let's try and create a new blockchain. Okay. So let's say this is our chain, and I am a shady validator, and I try and insert my block into this. So I create this block. Let us code it in a different color. So here I am. Now keep in mind that all these transactions are already validated. Let's say I just want to remove one transaction. I want to reverse a transaction. So this is block 3. So some transaction in block 3 which is there, and I don't want that transaction to happen. So I just create a new block. So I create this block 3.2, and I create a new chain. But again, for my chain to be accepted as the final chain, what needs to happen is that my chain has to be the longest. And let's assume, for a hypothetical scenario, that I actually have so much computing power in the world that I'm able to accomplish that. So what happens is I create new blocks, I create, and it has only this one has only 2 more blocks, but I create 4 more blocks. So now what should actually happen is that after here, my chain should be given priority. This red chain should follow. So anybody would like to answer why this would not happen, or why people who are trying to game the system don't have as much of a benefit as you might think? Can I go and change a transaction in backdate is the question. And if not, why am I not incentivized to do so? Because we have just seen that we are able to do this. So why should we not do this? Okay, so the creators of Bitcoin actually thought this through. So if, let's say, tomorrow somebody has so much computing power which won't be uh, okay, Natasha, we are losing the data in the 2 blocks behind. No, actually, that's not the thing, because whatever. Okay, so we have a previous hash as well, right? So till block 3, my previous hash contains all the data in these 2 blocks. So that's not an issue. So when I create block 3 too, because I have the previous hash of block 3, which contains the data in these two, I might be able to validate these two blocks and move forward. But why people don't do it even when they can is, firstly, nobody has so much computing power. A single person can only do this if they have more than 51% stake in the chain. So let's say tomorrow I have more than 51% stake in the chain. I have a great PC setup with multiple GPUs, multiple CPUs, so much of electricity just to keep mining Bitcoin, and I gain more than 51% stake in the chain. What happens is I can create new blocks at a faster pace than all the other miners around the world, because they will have roughly 49% stake, but I have 51%. But when I do so, I'm actually making more money just validating these transactions. Because let's say if you have 50% stake in the chain, every 20 minutes you can push a new block to the chain. Because as I told earlier, every 10 minutes a new block is being added on the blockchain network, on the Bitcoin network. So if I have 50% stake, every 20 minutes I can mine 3 Bitcoins. So the reward of just mining the existing chain overvalues the perceived benefit that I would have gained by altering this block. So that is one of the major reasons why it is not as beneficial to game the system. And like if I have that much computing power, I am much happier being within the chain and just validating the transactions that are happening on the chain than trying to go back in time and change certain transactions. So this was the main reason. Now moving on to other questions. So yeah, this can create forks. Sometimes in a chain, it is possible that at the exact same time, two different validators around the world are validating a different set of transactions, and they create a new hash in the blockchain. Now, the thing is, because they created at the same amount of time, both will be added to the blockchain, which will lead to a fork. How does this get resolved is, firstly, again, as I told, the longest blockchain is considered as the final blockchain. So it is roughly impossible. Let us say our fork started again at block 3. So from block 3, we started getting two chains, one blue chain and one red chain. Now, again, the thing is, when I have a fork, it is almost negligible chance that till 3 or 4 blocks, two validators are finding it at the exact same time. So eventually, what happens is after 3 or 4 blocks, one of them will actually be faster. Let us say the blue one is faster, and in the same time where the red chain has 3 blocks. After this, after this point, the blue chain was able to add a block faster. So this will be considered as my final chain. Then what will happen to these transactions over here? These transactions, would they be considered invalid? Or because that shouldn't be the case again, right? Once I have made a transaction and it is on the Bitcoin chain, it should stay there forever. So how do we move on to resolving forks? It is something that I said a few minutes back, if you can recall. Anybody would like to say? So we have something called as the mempool, yeah. So all these transactions would go in the mempool, and they would finally be selected by some validators around the world, and they will stay validated. It's not that these transactions would vanish into thin air. So yeah, we have seen how to resolve forks, and we also have seen that transactions can't be reversed, and the fact that trying to game the system is a bad way of staying in the blockchain. Rather, uh, like just validating the transactions within the blockchain is better. So up until now, anybody has any doubts? Because after this, we would be moving on to slightly practical parts like setting up a wallet and our IDE. So until now, anything you want to add on to the discussion or anything that you want to ask me, please go ahead. Like, we'll take a 5 minute break in case anybody has any doubts. How are you liking it till now? Just give a thumbs up if you're finding it enjoyable. Okay, thank you. So yeah, that's awesome. So we would now be moving on to wallets. Let's just take a quick 2 minute pause and then we'll move on. If any of you have any doubts, you can pop them onto the chat window or you can speak. Okay, so now let us move on to wallets. And I would request all of you to particularly focus on this part of the workshop, because if you stay focused till the end of the session and if you follow each and every step, you might just end up getting 411 dirhams on me. Okay, so let us first try and understand what wallets are. So, the majority of the wallets that we see in our day to day uses of cryptocurrency, can anybody name a few wallets that they know of? I did name a few in the start of this session.
Phantom?
Phantom, that's good. Yeah, it is a good wallet. We would be using that today as well. Apart from that, does anybody know of a popular Ethereum based wallet? Okay, so MetaMask is one Ethereum based wallet. So, what all of these are, be it Phantom or MetaMask or let's say Backpack, for example, these are hierarchical deterministic wallets. So, they can actually generate multiple public private key pairs from a single seed value. Now, again, this begs the question, what exactly is a seed value? Like, and why do we need a seed? So, seed is nothing but like a 512-bit binary value that can be generated from a mnemonic, or if you have it already, there is that. And using seed, we can generate multiple public private key pairs. So, like I showed you in the beginning of the session, I created one public private key pair on my local terminal. Using a seed value, I can create more than one public private key pair. So, as we can see in the diagram over here, like one seed, we have different derivation paths. So what you see alongside the arrow, this m slash 44 slash 60 slash 0, that is actually a derivation path. Now, derivation path is basically a systematic way to derive like keys from the seed value. So here, what M actually refers to is the master node of the wallet that we have in usage. And okay, so 44. So here, this is an interesting thing. So Bitcoin, the chain, actually has a thing where you can go and suggest improvements on the Bitcoin blockchain. So let's say tomorrow, if you have an idea to make Bitcoin better, you can go to their GitHub repository and raise a protocol. That protocol is called the Bitcoin Improvement Protocol. So in Bitcoin Improvement Protocol 44 is what defines the purpose of these derivation paths. So that is why the number 44 is there. Like, that is just the Bitcoin Improvement Protocol, which is the standard for the wallets that we use in our day-to-day lives. Apart from that, the next number is the type of cryptocurrency. So let us say tomorrow I create a new coin called the Raghu coin. I can go ahead and get myself a number which will represent my coin. So it is 0 in the case for Bitcoin, it is 60 for Ethereum, and 501 for Solana. Apart from that, so again, why the concept of seeds was introduced was because a single person can have multiple wallets. Okay, I can have maybe one wallet for all my personal needs, and I can have one wallet for all the official tasks that I may have. But since all this is managed through a system of public and private keys, remembering so many keys is a difficult task. So what happened was people like introduced the concept of seeds, that you just need a seed from which, using derivation paths, we can figure out multiple new public and private key pairs. So here the concept of mnemonic and seeds come into picture. So mnemonic is actually a human readable sentence. It is actually a set of 12 words that if you know those 12 words in the exact order, you will be able to figure out the seed. And using that seed, we will be able to figure out our public and private key pairs. So that is basically the concept of mnemonics and seed. So mnemonic will lead us to the seed, and finally seed will lead us to the different key pairs that we have. So here is a diagram again. So mnemonic, as I told you earlier, it consists of 12 words. That will get me the seed, and seed will get me the. So again, like from this main seed, using the different derivation paths, I am getting seeds of different wallets. Basically, the way it is done is like this last zero or this last one, that will be different for different wallets, and hence I get various public and private keys. So now this is a very good thing. Now all I need to do is remember 12 words in a particular order, and I don't need to remember anything else. Because see, like remembering public and private keys is not an easy task. Even if I show you guys my private key, which is this OpenSSH private key over here, chances are very slim that unless and until you maintain a digital record of this, that you will be able to remember this for a fairly long period of time. So the only option that is left is pen and paper. Now, once we are saving them in pen and paper, like storing a lot of values becomes difficult. You will be maintaining diaries and diaries of keys just to access a few wallets. So that is where the concept of mnemonics came. Let me try and share a GitHub repo, which is of the actual Bitcoin improvement protocol, which gives us the set of all the words that we can use as mnemonics. Give me a second. Yeah. Just a minute, guys. Yeah, here. So in this window, we have a set of how many? We have 2048 English words that can be used in generating our mnemonics. So this is the actual GitHub repo of BIP, wherein in the protocol, in the 39th protocol, BIP 39, Bitcoin Improvement Protocol 39, we were given a set of 2048 English words from which you can choose any 12 in a particular order, which will give you your mnemonic. And again, as I told you earlier, that mnemonic will get you your seed, and then seed can be different for different wallets, and then you can just like So where this comes in handy is, let's say I'm using Phantom, okay, and I have stored, let's say, some amount of Ethereum in Phantom. What I don't want is Phantom to have access to my Ethereum. Let's say tomorrow I want to switch to a different wallet, say MetaMask. I should be able to do that. But again, in order to do that, I need my public and private keys, which, if you have multiple wallets, is a mammoth task. So whenever you create a wallet, a new wallet nowadays, you are given a set of 12 words in a particular order, which, if you remember, you will find access to all your keys. Now, let us get hands on and let us try and install new wallets. But before that, once we like move ahead, you will see that all the wallets that we are seeing, they are actually Chrome extensions and not actual websites. So does anybody want to answer why that is the case? Why do we have Chrome extensions in our sorry, I muted myself by mistake. So anybody wants to answer that? Okay, so the main thing is, whenever you access a website, okay, there is a backend of that website. Let's say tomorrow I create a wallet called the Raghu wallet, and I ask everybody to like use my wallet instead of using Phantom. The major issue is that when I'm using Raghu wallet and it is a proper website, whenever you enter your private key or whenever you enter your mnemonic, that has to be stored somewhere on my database, which again, like, just doesn't justify when uh, uh, our entire reason behind introducing blockchain and cryptocurrency as a whole was decentralization. So like, my public key sitting on a server somewhere just defeats the purpose, right? So now I have created a new Chrome profile, and I'll be sharing step by step how to install a wallet and how to just start accessing it. So just let me know if you can. Okay, this is my normal Chrome. Wait a second. Yeah. So this is a brand new Chrome profile that I created just before joining this session. And what we'll search for is, let's take Phantom wallet extension. If you can just search it alongside me, so that will make it easier because I'm anyways doing it, so why not you as well? Add extension. So now, yeah, answering to the question, like, why are we using extensions and not website? So whatever Chrome extensions we use, firstly, it is supported on all the websites. So let us say tomorrow I am using a DApp. DApp are basically decentralized apps. So any app or website in the Web3 space, for example, if you have Phantom, I it is cross website. Like, it is not supported with one website and not supported with another website. Whichever website I open in my Chrome tab, Phantom will be supported because it is an extension. That might not be always true for websites. And secondly, as I told you earlier, websites will always have a backend, and my private key might end up getting stored on that backend, and that anyways defeats the purpose. But whatever is stored on these Chrome extensions is not stored on any website but stored locally on my computer. So unless and until there is an existential threat to my computer, or like, let's say, some malware which directly affects my computer, there is no way that a third party can gain access to my wallets. So let us try. How many of you have actually tried and installed this extension alongside me right here. Okay, that's great, Athar. Okay, Sean. Okay, that's good. Great. Many people have done that. So we'll just click on create a new wallet. Seamless setup. We don't need any email. Okay, that is the purpose of decentralization. What we'll do is create a recovery phrase wallet. Anybody wants to take a guess what this recovery phrase might be? Just a random guess. Switch on your mic or put it in the chat box.
Like a password?
Not a password. It is something I discussed about 5 minutes back. Okay, it is the mnemonic, guys. Okay, so as soon as I click, it will ask me for a password. You can enter any password. This password is not the password which will let us access our wallet. Be careful. This is a password which will just let me open the Phantom extension. So once I open the Phantom extension, it's not that I have access to all my wallets. The access to the wallet will be determined by a 12-word sequence called the mnemonic. And as I just did this submit button, I should be getting my 12-word mnemonic. So yeah, recovery phrase. These are the same 12 words that I talked about. And each of these words, island, monitor, the GitHub repo I showed you earlier, if you go ahead and try and find this word, you will find all these words within those 2048 words that we showed earlier. And this is the exact sequence in which you will have to put in the words. Let's say tomorrow, if you want to transition to a different wallet, this is the recovery phrase that you will want. And it is generally advisable to save the recovery phrase on pen and paper, because again, storing it digitally, you might end up backing up your computer to some cloud service. Again, that cloud service is a centralized cloud platform, and it defeats the purpose of decentralization as a whole. So I'll click on continue. Soundwine5593. You can try and experiment with the username. I won't change it for now. So right now it is creating a wallet. So hi Soundwine, you're already get started. So on the sidebar you can see. So this again, I enter the same password I created a few minutes back. This will unlock my Phantom extension. Now here you can see I have a one account one. Now this account one has different. These are the public keys. So let's say tomorrow I want to like just I want someone to send me a certain amount of Ethereum. I'll copy this, I'll send it to the guy, and using this public key, they can send me X amount of Ethereum if they want. But here now what we'll try and do is you can create new accounts as well. So account one. So account one might be for my personal tasks, and I just create a new account, account two. This account has again different public keys. So this is might be for my professional tasks, and this is for my personal tasks. Now let us see how we can migrate to a different wallet. I'll try installing, let's say, Backpack for me. Okay, sorry, Backpack Chrome extension. So this is the actual extension of Backpack. You can just add it to Chrome. It says Backpack. It can read and change data on all websites. So as I told earlier, the Chrome extensions that we install, they have access to all the websites that we like use. So let's just pin it over here. So now let's say on Backpack, I say I already have a wallet. And let us say I have an Ethereum wallet. I can also use the recovery phrase, but because I haven't done any transaction, it is a personal drawback of Phantom itself that if you haven't made any transaction, it doesn't allow you to use the recovery phrase. So for now, we'll use the private key, and let us see. Ethereum, just remember that 0x7196 is the start of our Ethereum key. Now let us try and get our private key. We'll go to settings, manage accounts, account one, show private key. Again, this is the password to access my Phantom wallet. Now, Ethereum private key, I'll ask. I'll click on show. This shows me the Ethereum private key I have of the wallet that was created by Phantom. Now I'll go ahead and paste this onto Backpack. I'll click on import. Again, it asks me to set a password. I'll set a simple password. I'll click on next. Open Backpack. Mm. So yeah. So as you can see, imported wallets I have 0x7196. What I had here in Phantom was 0x7196. So this wallet that has been created on the Ethereum blockchain for me by Phantom has no access to whatever assets I store on this wallet, because as you can see, I can access the same wallet through Backpack also if I want to. So let's say tomorrow I stop liking Phantom and I like prefer Backpack, I can do the same without any issue, because the public key of the wallet that I have is the same, 0x7196, and the ending is with 1BDE. So how many of you have actually tried this alongside me? Has anybody got in public key or a different one? किसी को अलग तो नहीं है? Anybody with a different public key? Show of hands. Okay, no one. Thank God. So yeah, that is how you actually create wallets. And now this public and private key that I have is very similar to the public private key creation that I did on my local terminal. It is just that accessing and managing everything to terminal is a tough task. Let's say tomorrow we have our own project and we want that project to interact with the blockchain. We don't prefer every time going through the terminal. So these wallets just add a simplistic UI and help us navigate through our own wallets. Now, coming to the main important section, first let us try and create a MetaMask wallet, because that is the most widely accepted wallet for Ethereum developers. So what we'll again search is MetaMask Chrome extension. We'll go to this website, the first link. We'll click on add to Chrome. And just for a nice habit, I just installed Phantom and Backpack for showing you how your blockchains aren't linked to your wallet, but actually on the Ethereum chain. So when we create our Phantom wallet, just create a new account and that will give you a new key. So create a new wallet, use secret recovery phase. Again, this recovery phase is the mnemonic. And if I forget my password, I can't reset it and all my data would be lost. So let's say tomorrow I become a millionaire and I put in like 10 Bitcoins worth of US. I mean, I just put in 10 Bitcoins onto my MetaMask wallet. Let us say if I forgot this password right here, I would be down to a homeless person the next day. So it is really important to like just save this password either on pen and paper or in your mind, however you want, but this can't be reset. Here again we get a mnemonic. This is my mnemonic for MetaMask, which was different for Phantom. So different wallets create different secret phrases, but again, using this secret phrase, I can use a different wallet and import all my accounts. Continue. Oh, it asked me to reconfirm. I didn't see it very properly. Okay. I just took a screenshot, but it is not a good habit to save it digitally. So second one was tree. Fourth, seventh one was setup, and this was continue. Perfect. Gather basic data, product updates. Continue. Your wallet is ready. Open wallet. So as you can see in the sidebar, this my MetaMask wallet has been set up. Now, coming on to the part for which all of you might have been waiting, the 411 dirhams. I mean, there was a small caveat in that slide, which was those will be testnet Ethereums. So sorry to disappoint you guys, but you will get 0.05 Ethereums. So let us just go to Google Cloud. One second, sorry. Hmm. Sorry, just a small change. Before we do that, what we want is, I'll just share the steps once more. So when you have this wallet over here, you have your accounts. So this is account, and this account has multiple wallets. I mean, multiple chains. I can see here I have Ethereum, I have Bitcoin Native, I have Solana, I have Tron. I can do view all, and I can see different accounts and addresses. So this is my public key for Ethereum wallet. This is my public key for the Solana chain. Now what we'll do is we'll click on these three lines. We'll navigate down to network, and what we'll do is we'll do show test networks. So test networks are basically like, let's say tomorrow we create smart contracts. We would be diving deep into what are smart contracts and how we write them in the next session, that is tomorrow. So tune in for that as well. But let's say we have one smart contract and we want to just test it without putting it out on the actual Ethereum blockchain. So I think I didn't show the slides. I'll share it if time permits. The major benefit of Ethereum is that Bitcoin was just like a transfer of money kind of a chain. Right? If, let's say, two of us use Bitcoin, I can send you some Bitcoins, you can send me some Bitcoins. But the benefit with Ethereum was it gave us the flexibility to create something called as the smart contracts. Smart contracts are written in a language called Solidity, again, which we would be covering in the next class. But this added advantage again allowed me to create my own coins. It also allowed us to create stable coins. So, how many of you have heard of USDT and USDC? They are coins pegged to the US dollar, so their value is exactly same as the US dollar. So Ethereum permitted that as well. But again, the highlight of Ethereum as a chain was that I can create smart contracts, which are just lines of code which I can store on the Ethereum chain and execute them. This is done using a thing called the Ethereum virtual machine, but running smart contracts on the Ethereum virtual machine requires me to like put in e- some Ethereum as a, let's say, as a fees of using the blockchain. So what test nets do is they give us some credits, let's say, like just like Google Cloud credits. So you get credits for blockchain as well. So those credits we can utilize for testing the smart contracts that we would be writing in the next session. So yeah, that's about it. So we'll just do show test networks, and Sepolia is one of the most common ones. So we would be using Sepolia itself. But now you can go on to Google Cloud Sepolia Faucet. So using this, we would get 0.05 ethers as a complementary thing, for which we will need the wallet address. Again, see carefully here when I go to, if I copy this, this would be my wallet address. I'll paste it over here. I'll get 0.05 Sepolia Ethereum. But if you convert Ethereum, that's about 411 dirhams. So sorry for the like baiting you guys into staying this long, but I hope you enjoyed it. I'll just sign in with my Google account. Uh, so anybody trying this alongside me? Okay, that's great. So just log into this Google Cloud faucet and put in your address. You will get 0.05 ethers as a test amount. I'll just try and demonstrate that over here. Okay. It's done here. I'll just search it again. So I'll just paste my public address, public key over here. I'll do get Sepolia ATH. Testnet tokens are in queue. So this transaction hash, as I told earlier, all the transactions that are done on the blockchain, we need to find cryptographic hashes, which is the proof of work. So that is for Bitcoin. Ethereum uses a slightly different concept, which I'll just cover. So this transaction hash is actually proof that I am getting this. And recipient, as you can see, would be my address, public Ethereum address 0x036BA, 0x036BA. So if we just refresh the wallet, it works, guys. I've tried it. It just takes some time to refresh. Till then, I'll show you another MetaMask account of mine on which I got this zero point 0.5 test Ethereum, so 0.05 test Ethereum, so that you guys believe me. Just a second. Okay, can you guys see my screen? So yeah, once the transaction executes and it is there on the blockchain, you will get uh, 0.5 Ethereums. Can you see my screen? Like, can you see the wallet? Wait a second. Yeah, now you guys would be able to see, right? So this is how you'll get, these are test Ethereum. So now with these 0.05 ETH, we can try and run whatever contracts that we write in Solidity onto a test Ethereum network, which is powered by Sepolia. Now, just one small thing that I want to cover is just getting you familiarized with the IDE that we would be using. So for writing smart contracts in Solidity, we won't be using VS Code, but we would use something called as the remix IDE. So I'll just show you and we'll write a small code, and that should be good enough to wrap this session. So just stop sharing and share that. So yeah, believe, trust the process, guys. You will get your 0.05 ethers. Now remix ID, just search it up, or like you can directly go to the link, which is remix.ethereum.org. You can download it as well, but it works perfectly well online. So it will open up a window like this. We can accept this, and it is pretty similar to VS Code. So here we can create different contracts. So let us try and implement a very small, simple logic using Solidity. And for our in our advantage, Solidity is an object-oriented language. So it is somewhat similar to Java in terms of syntax. So as I write the code, you'll probably be able to understand what we are doing. And if you guys have any doubts, just like switch on your mic or put it in the chat box. So we'll create a variable called hello world, and the extension for all Solidity files is .sol. So here what we'll do is, first we need to define which Solidity we are using. So we'll do pragma Solidity, and we can put in a model, or if we use this caret symbol, it automatically uses the latest available version. So again, this line, pragma Solidity, this will just tell the compiler to use the latest available version of the 0.8 dot whatever this decimal place will be updated to the latest version. Then we will, just like we define classes in Java, we will define contract. So that contract should be called hello world, and we'll start writing that. So we'll create a string public greeting. Okay, and again, inside a class, what all was necessary in Java? Anybody remembers? What is absolutely necessary in a Java class? Okay, constructor, guys. So here also we would be having a constructor. So we'll just call in the constructor over here. One difference being that the constructor is actually like just called as constructor and not same as the contract name. So again, in the constructor, we will initialize greeting to hello world. It actually recommends me, yeah, hello world. That is done. Now we'll just create the get greeting and set greeting function. So getter and setter, that will finish the code. Function get greeting. Okay, so here there's some syntax which, as and when we move on, you guys will understand better in tomorrow's session. Just stay with me for now. I'll just tell you how to execute this, and then we can end. So this will actually help us view whatever greeting we have. In this case, get greeting. Why is this? Okay, sorry. We need to return greeting only, not get greeting. Now we'll create the setter function. So if we want to change the greeting for to any other thing, we can do that using the set greeting function. So that will actually take in a parameter of new greeting, just like we did in Java. String memory. So yeah, that is it for this code. So okay, yeah. Now it tells me infinite gas. So gas is something that we actually need to spend to run contracts on the Ethereum blockchain. We'll cover it in more detail in the next class. For now, we can click on compile over here. So okay, there is some issue. Warning. In the source file comment. Okay, for simplicity, we'll just okay, we need to add the license. Okay, yeah, sorry. And we'll just change it to use this model that is actually the latest model. And here we'll have spdx dash license dash identifier. This is just like a boilerplate code for this. Singularity.
Is it identifier what you're supposed to write? Or
Yeah, sorry. Yeah, now yeah, so it got compiled. So here, so we are usually in the file explorer page, which shows all of our files. Then we can move on to the Solidity compiler. Here we will compile this code, and once we have done that, we can go ahead and deploy. So this value and gas limit, again, we would be covering in the next session. Here, if we go ahead and deploy, we see one deployed contract, hello world. And here we have three functions: set greeting, call. One we can call the get greeting, or we can call the greeting directly also from the constructor. So let us call greeting, call, that gives me hello world. Even if I call get greeting, that will also yield me hello world. Now, if I call set greeting, I can specify some value here. Let us say namaste, and I click on transact. Again, this transact and all would be covered subsequently. Now, when I call this, it is showing namaste. So this is a very simple Solidity code. You can try experimenting with the wallets and Remix IDE. You can try installing this IDE locally as well. So there is an app which we can use to run Solidity contracts. You can try that. You can experiment with that. You can experiment with the 0.05 Ethereums you might have got with the Google Cloud Sepolia test network, and just try and figure out anything that you want. In the next class, we would be covering again, we would be having a small like recap session, and then we'll be moving on to smart contracts. Thank you, everyone. That's it from my side. I hope you guys liked this session. Just give a thumbs up or something in the chat. And everybody has did all of you try Remix ID coding while I was doing it? Because that's the main point of coding it live, so that all of you can see. Okay, thanks a
I
lot,
didn't get
everyone.
namaste part. Like
Okay, we would.
I tried
So did
follow,
it?
but then the namaste part didn't. I didn't know what to do there.
Okay, so that what we do is, you have the set greeting function, right, in your contract.
Yeah.
And have you equated that greeting is equal to new greeting?
Yeah.
Okay,
The
I'll
code
just
I followed from your screen.
okay, I'll just share my window for a few seconds. So here you have to click on set greeting function. Here, instead of namaste, now we can yalla, and you have to click on transact. Once you click on transact, it is like we have executed. Now this yalla is the new greeting. Now when we call get greeting, it will give us yalla.
Should we click deploy before that?
No need. Okay, you haven't clicked deployed yet, is it?
Yes.
Okay, yeah. You click deploy first. Once you click deploy, it will open a window like this on the Remix virtual machine, and within this, you will get these three functions. Understood?
Yes, got it.
Okay. Thank you so much. Okay, yeah. So thank you guys. That was it. I hope you liked the session. We would be joining in tomorrow again at the same time and moving forward with coding actually on Solidity. So please do join. Thank you for joining today. This is it for this session.
Thank you.